Quick, graph y equals the absolute value of the quantity 1/3 x by hand 2 different ways. It is highly recommended that you watch the video How to Graph y equals f of the quantity k times x before watching this video. You will need graph paper or download this PDF and print it, and press pause as needed anytime during the video. The first way is with the absolute value dance. Normally we start at the origin and the coefficient of x 1/3 inside the function does not affect this point, because when we substitute x equals 0, y is also equal to 0. Points are going to be plotted relative to this point, the origin. Since k equals 1/3, the graph is wider than the parent function, y equals absolute value of x. And also recall that the coefficient, k equals 1/3, is inversely proportional to the horizontal dilation factor, 1 over k, or the reciprocal of k. That is, multiply each x value by the reciprocal of 1/3, which is 3. Normally the absolute value dance would be right 1, up 1. But for this one, we're going to multiply each x value by 3, so it's going to be right 3, up 1. And so we'll plot that here. Next, it would be right 2, up 2 normally, but we're going to go right 6, up 2, again, tripling that x-coordinate 2. Right 6, up 2. And right 3, up 3 becomes right 9, up 3. Going on the other side, left 1, up 1 becomes left 3, up 1. Left 2, up 2 becomes left 6, up 2. And left 3, up 3 becomes left 9, up 3. Connect the points and compare it to the parent function y equals absolute value of x. Notice we're going to multiply each x value by the reciprocal of 1/3, which is 3. And you'll notice here the blue and the green point have the same y coordinate, but the blue x coordinate times 3 is the green x coordinate. Not just for those 2 points, but for these 2 points, and all the points on the graph. We call this a horizontal dilation factor of 3, a horizontal stretch. And also I'll point out, since the absolute value of the quantity 1/3 x is the same as 1/3 times the absolute value of x, those graphs are identical. And one is in orange and one is in green. Second way, using a table. Here's our normal absolute value table with 5 points in it. Since k equals 1/3 inside the function, the coefficient of x, the horizontal dilation factor is its reciprocal, 3. And we keep the y coordinates the same, so create that table with the y coordinates the same. But we multiply each x coordinate by 3, 1 over k, which in this case is 3. 2 times 3 is 6, so we'll plot 6, 2. 1 times 3 is 3, 3, 1. The origin remains unchanged. Negative 1 times 3 is negative 3, 1. And negative 2 times 3 is negative 6, 2. Connect the points. And again, compare it to the parent function. We have a horizontal stretch. Now you try one. Graph y equals the absolute value of the quantity 1/2 times x. Use either method or both for the practice. Press pause to do this and then resume when you're finished to check your answer. And here's your answer. Notice in the green it is a horizontal stretch. Slopes are 1/2 and -1/2 for the green.